Welcome to Demystifying Math. In this lesson, we're going to be rationalizing. We often need to rationalize either numerators or denominators of fractions in order to evaluate limits. In this lesson, we're just going to focus on the rationalizing. Let's start off with this expression. We have 1 over the square root of x, and what we want to do is rationalize the denominator, or in other words, make a rational number in the denominator instead of a radical. And we can do that pretty easily by multiplying the numerator and the denominator by the square root of x. Then multiplying straight across, we get the square root of x over x. Now, when you are done rationalizing, the domain of the original function should be the same as the domain of the simplified form of the function. If it's not, always make sure that you make a domain restriction notation to make up for that. Okay, so looking at the original function, if you put in a 0 for x, you could take the square root of 0, but then you would be dividing by 0. So we would not include 0 as part of our domain, but we can include everything above 0. The same thing holds true for the simplified form. Your denominator cannot be 0, and your radical can't have any negatives under it. So your domain is going to be from 0 to infinity as well. For our second problem, we have the x over the square root of x minus 1. We're going to rationalize the denominator again, and this time we're going to multiply by the square root of x minus 1 over itself. Then we'll multiply straight across. So we get x times the square root of x minus 1 all over x minus 1. Now looking at the original function, the domain is everything that's greater than 1. We have to be strictly greater than 1 because putting a 1 in for x in our denominator would cause us to have a 0 in the denominator. So we can't do that. So our domain is strictly greater than 1. Here's our next problem. We have 2 over the square root of x minus 5. And we want to rationalize that. And we're going to be able to rationalize it by multiplying numerator and denominator by what we call the conjugate. The conjugate is simply the same thing except the change of signs in between the two terms. So we have the square root of x plus 5 that we're going to be multiplying numerator and denominator by. Then multiplying straight across, I distributed the 2 to the x and then to the 5. So I got 2 square roots of x plus 10. Now in our denominator, when we multiply by that conjugate, we have a sum difference. So our inner and outer terms are actually going to cancel each other. So all we have to worry about is multiplying our first terms together, and that's going to give us x, and our last terms together, which is going to give us the negative 25. Now again, you want to look at your domain. On the original function, we could not put anything in for x that's less than 0. We could put in 0, that's not a problem, because we would just simply end up with 2 over 0 minus 5. But we can't put in a 25, because if we do, we'd end up with 5 minus 5 in our denominator, which would give us a 0. So we're excluding 25, including 0, and excluding everything below 0. Now in this case, the same thing is going to hold true for our simplified form. The 25 can't go in your denominator, and anything that's negative can't go in the square root of x in the numerator. So we have the same domain. We want to rationalize the denominator of 1 over the square root of x plus the square root of x minus 1. So we're going to multiply again by the conjugate, and then multiply straight across. So we end up in our numerator with the square root of x minus the square root of x minus 1. And in our denominator, all we have to worry about is multiplying our first terms together, which is going to give us x, and our last terms together, which is giving us the x minus 1. Remember, your inner and outer terms are automatically going to cancel each other. Then we're going to simplify our denominator, which ends up, when you distribute the negative, as being x minus x plus 1. So the x's are canceling each other, and you're just left with 1 in your denominator. So our final answer is the square root of x minus the square root of x minus 1. Now our domain for this problem is going to be greater than or equal to 1. So we can include 1 in both of the original function and the simplified form. Okay, for our next problem, we want to rationalize and then add. So we're going to rationalize the second term. We're going to multiply numerator and denominator by the square root of x minus 1. And then simplifying that, we get the square root of x plus the square root of x minus 1 all over x minus 1. Now what we want to do is add them, so we need a common denominator. So we're going to multiply the first term by x minus 1 over itself. Then I distribute the square root of x and to the negative 1. And then what we're going to do is look at our domain. So in our original function, we could not put anything less than 1 in because of our denominator being the square root of x minus 1. And we also could not put in a 1 because that would have given us a 0 in the denominator. The same thing holds true for the new form. If we put a 1 in our denominator, we would have 0 in the denominator. Okay, for our next one, what we're going to do is subtract, then rationalize. So we're going to find our common denominator first. Multiply numerator and denominator by 2 over the square root of 1 plus x. We end up with 2 minus x over 2 times the square root of 1 plus x minus 2 times 1 plus x. And I got the 1 plus x by multiplying the square root of 1 plus x by itself. And then you want to bring your two terms together. So we're going to distribute the 2, actually a negative 2, to the 1 plus x. So we end up in our numerator with 2 minus x minus 2 minus 2x. And then we just combine like terms and our numerator becomes negative 3x. Now with this one we still need to rationalize. So we're going to multiply numerator and denominator by the square root of 1 plus x. So we have negative 3 times the square root of 1 plus x all over 2 times 1 plus x, multiplying straight across. So then I just distributed the 2 in the denominator. Now the domain of this problem is from negative 1 to infinity, not including negative 1. Okay, for our last problem, we have the square root of x minus the square root of x plus 3 all over 9. And this time we want to rationalize our numerator. So we're still going to multiply by the conjugate, but this time the conjugate of the numerator. And then we're going to FOIL the numerator. So we take the square root of x times itself, which gives us x. And the square root of x minus 3, or x plus 3 times itself, gives us x plus 3, and it's subtracted because one term was positive and one was negative. Then we're going to distribute that negative to the x and to the 3. So we have x minus 3, which is going to give us negative 3 in our numerator. Then we want to put the negative 3 over 9 in lowest terms. So we end up with negative 1 over 3 times the square root of x plus the square root of x plus 3. The domain for this function is greater than or equal to 0. Okay, thank you for tuning in to Demystifying Math.